Welcome to the technical video submission for IICDC 2019 Interim 3. Let us start with the problem statement. We often get our eyes strained while traveling in a car during the night whenever there is an opposite vehicle approaching towards the car you are in. This happens because the high beam intensity from the headlamps are made to illuminate the darkness in front of the vehicle so that the driver has a clear path ahead of him. The headlamps of the car can produce 2000 to 3000 lumens of brightness intensity depending upon the type of bulbs used to make the headlights. And due to such high brightness level of these headlamps, there are numerous accidents in highways and it is increasing year by year. Hence, we have come up with an innovative solution, that is, we are going to interface a custom-made circuit with directly to the circuit of the car, so that whenever a car approaches with a high beam of light towards another car within a particular range, the car's headlight will automatically switch to low beam of light so that there is no confusion of the cars approaching towards the vision of the driver. After the car has passed, the lights switch back to the normal beam lights so the driver has a clear path ahead. For the first part of the demonstration, we have come up with an idea for changing the level of brightness of the headlamps by using a device called as LDR or light dependent resistor. So let us first try to understand the flow of current in the LDR. So here is a simulation of a simple LDR circuit with a light source. So as you can see, the ammeter reads a certain microampere reading. So as soon as I increase the amount of intensity on the surface of the LDR, the value increases from 5.45 to 59.7. So as the photons emit energy, the flow of current is only in one path and the other path is almost nullified. So now as soon as I bring back the source from the LDR, so the values drop back to the same as before as the 5.45 microamperes. So hence from this we can observe that by different light intensity the amount of current from one path to the other path changes. For the second part of the demonstration, we will show you how the current is made to travel in two different paths in the circuit by activating the LDR by emitting a light of high intensity directly over it. So as we told you before, the custom circuit for the car to be interfaced, so after implementation on an actual PCB, it looks something like this. So now let's see how the switching principle works. Now this is the working demonstration of the switching circuit. Now the right side of the LED is glowing. So as soon as I put light energy on the LDR, which is in the middle, the light switches from right to left. And again, if I switch off, the light switches from left to right. In the third part of the demonstration, we have combined all the components of the circuit and made the situation as realistic as possible with the model car approaching towards another car. In this model car, the high beam of the car is represented by red LEDs and low beam of the car is represented by green LEDs. The LDR is mounted on the front bumper of the car. As the light normally falls from another car, illuminates the front of the car, first in a particular range of a distance between them. Now while driving in the night, people normally choose high beam as their default mode of selection for driving. So hence this circuit also shows red light as the default light in the dark instance of the circuit, and since the LDR is also not receiving any kind of light, so the circuit is not activated. The problem during this experiment is we didn't have a light source with such a high intensity, hence the circuit shows both the lights activated at some instance of the time, which is not possible in the real-time application as the headlamps of the car have a really high intensity light, so at a minimum distance the circuit normally switches on. So now, as soon as the car starts moving towards the light source, we can observe the amount of light falling on the surface of the LDR in front. And for a particular distance from the light source, the car switches from red to green. This means it had automatically switched from high beam to low beam. And now with low beam, the driver has a clearer vision of the road and the vehicle ahead of them. Since this happens automatically, driver can concentrate on what's ahead of him rather than being disturbed by the high intensity of light falling on his vision and disturbing his actions.